Welcome to This Explainer. You know, behind every sleek business dashboard, behind every cutting-edge machine learning model, and honestly, behind pretty much every major data-driven decision you make, lies a completely hidden infrastructure. It's this vast, unseen plumbing system that literally powers modern data analysis. Today, we're going to slow down and carefully unpack exactly how this hidden world works. We are demystifying data engineering and the entire ETL pipeline.
Here is the blueprint for today's explainer. We'll start off with a core data problem, clarify the real difference between engineers and scientists, dive deep into extract, transform, and load, apply it all to a theoretical widget pipeline, look at staging and validation, and finally, wrap up by surveying the modern data toolkit.
All right, section 1, the data problem.
To truly appreciate the solution, we first have to understand the chaotic reality of modern business data. Picture this. You're at an online retailer selling widgets globally. The CEO walks in and asks a seemingly simple question. How many blue widgets did we sell in the last quarter? Well, in a small, local mom-and-pop shop, you just run a quick query on a single database and you're done. But for a global retailer, getting that answer is surprisingly difficult. Why? Because the sales data isn't sitting in one convenient place. It is scattered all over. North America has one database, Asia has another, and Europe has a third. You can't just ask one database. You're dealing with a highly fragmented, chaotic reality.
And this chaos is governed by what we call the 3 V's of big data: volume, variety, and velocity. Raw data is inherently messy. It arrives in a massive volume that traditional, old-school querying just can't handle. It comes in a huge variety of formats from all those different regional systems, and it's moving at a staggering velocity that demands near real-time processing.
We aren't just moving a few hundred records around here. We are talking about millions. Millions of rows, millions of unique records, millions of transactions happening every single minute of the day. You simply cannot manually sort through millions of scattered records. You absolutely need specialized automated data pipelines just to tame this massive flow.
Which brings us to section 2, engineers versus scientists.
Let's clearly define the unsung heroes who actually tame this flow. Data engineering is the development, operation, and maintenance of data infrastructure, whether that's on-premises or up in the cloud. It comprises the databases and the pipelines required to extract, transform, and load data. Simply put, this is the foundational plumbing. Without it, absolutely no analytics can happen.
Now, we hear a lot about data scientists, right? The brilliant people who build complex statistical models and perform high-level mathematical computations. But here is the catch. Data scientists cannot extract insights out of thin air. They rely entirely on data engineers. It's the engineers who build the infrastructure, who understand the diverse data formats, and who physically structure and move the data. A scientist literally cannot do their math until an engineer has successfully built the pipes to deliver clean data.
Section 3, extract, transform, and load. Let's get into the core mechanics of how this digital plumbing actually operates. This is the sequential journey of the data pipeline, widely known in the industry as ETL. Step 1 is extract. That means querying and pulling data out from the original source databases. Step 2 is transform. This is where we take that raw, messy data, clean it up, standardize it, and modify it to perfectly fit our needs. And step 3 is load. That's placing the newly cleaned data into its final destination, usually a data warehouse where it is finally ready to be analyzed.
Think of it exactly like a municipal water system. As the saying goes, the data comes into the pipeline raw or dirty and is cleaned as it flows through the pipe. Just like taking muddy river water and running it through a treatment plant to deliver clean drinking water right to your tap, a data pipeline purifies the messy input from global databases and delivers perfectly structured data straight to the end user. Moving on to section 4, the widget company pipeline.
Let's ground these abstract concepts in a concrete, real-world scenario. We're back at our global widget retailer. First up, we extract the source data. But remember, the United States alone has 4 different time zones, so the data moves into the transform phase. Right here, we might add a location tag to clearly distinguish the region and transform all that local time data into a uniform standard, like GMT. Finally, once it's clean and standardized, the data is loaded into its ultimate destination. If we zoom in on the actual data flowing through these pipes, look at how the raw JSON code evolves. Initially, we just have an ID, a price, and a local date. Pretty basic.
But as it moves through the pipeline, it physically gains new tags. A location tag is added for Europe. The date structure changes from a casual local format to a rigid standardized format. This is the exact transformation happening in flight, right before your eyes.
Section 5. Staging and Validation.
When you're dealing with millions of records, things will inevitably go wrong. So we need safety mechanisms to keep these massive data pipes from bursting. The absolute most critical safety mechanism is staging. Why do we need it? Because transactional databases are moving incredibly fast. They are constantly updating every single second with new sales. If you extract a batch of data, try to transform it, and your pipeline happens to fail, well, you cannot just go back and run the exact same query again. The database has already moved on. New records are there, old ones are modified. You'd completely lose that original snapshot. Staging means we temporarily save the raw extracted data into a file before we do absolutely anything else to it.
In a modern pipeline architecture, you'll see specific steps added just for this. Put staging file and get staging file. These act as your critical safety nets. By staging the data to a file immediately after extraction, engineers can safely debug any downstream transformation errors without ever losing the original raw extract. You just pick up right where you left off. It's a real lifesaver.
Now, right alongside staging, we have validation. Think of validation as a strict quality control checkpoint. Before any data is loaded into your pristine data warehouse, the pipeline runs automated checks. It ensures that text strings aren't mistakenly being loaded into date columns. It verifies value ranges, for example, ensuring a car's recorded speed is an actual number between 0 and 200, and not just the letter H. It confirms that all your mapping is completely accurate.
Finally, Section 6, the Modern Data Toolkit. Let's look at how this whole discipline is evolving alongside some incredible database technology. A data engineer must pick the exact right shape of pipe for the right job, and this table lays out the core choices. Relational databases, like PostgreSQL, store data in rows and columns. They are perfect for carefully recording point-of-sale transactions. Then you have columnar databases. They store data in columns, making them incredibly fast for data warehouse queries when your analysts need to read massive amounts of data all at once. And finally, NoSQL databases, like Elasticsearch, store data as JSON documents, which makes them absolutely brilliant for handling highly varied and flexible data formats. But here is the major takeaway I want you to grasp today. It's a massive shift in how modern pipelines are built. We've spent this explainer discussing ETL, extract, transform, load, where transformations happen in flight. But right now, there is a massive industry shift toward ELT, extract, load, transform. Because modern data warehouses are now essentially supercomputers, it's often way more efficient to just load the raw data directly into the database first, and then use the database's own immense computing power to perform all those complex transformations. There is no right or wrong way here. It depends entirely on your specific use case. As we wrap up this explainer, I want to leave you with one final thought to reflect on. Take a hard look at your own organization through the lens of a data engineer. What chaotic raw data is flowing through your business right now, just waiting for the right pipeline to extract it, transform it, and load it into pure actionable insight? The plumbing is out there, just waiting to be built. Thanks so much for joining me, and keep exploring the hidden infrastructure that powers our digital world.